what would this sound like? Now, I just told you that we can't run fast enough to hear this shift. But suppose instead of running, we were like my dog. Whenever we're in the car, they like the windows rolled down and they hang their head out there. Let's say you're in a car going 30 miles an hour towards a source, a whistle or a siren. And you get closer and closer, always going 30 miles an hour. So tell your neighbor, what is this going to sound like as you get closer and closer to the whistle, to the source? Talk to your neighbor. What's it going to sound like?
Frequency. It's going to sound like the stationary or closer to the stationary sound.
Well, that was good stuff. Okay. The point of this exercise is that there are two things that often get confused: the loudness and the pitch. Now, the loudness is related to the amplitude of the wave. Okay? And that's going to get bigger the closer you are to the source. It's going to sound louder, meaning that the compressed regions are going to make a bigger assault on your eardrums, pushing them further in and pulling them further out. The frequency, the pitch, is how often those compressions push your eardrum in per second. Now, if I had a source, a whistle, that had a frequency right here, we call that the rest frequency. Because you're going towards the whistle, it would be the same if the whistle were going towards you. Because you're going towards the whistle, there's going to be a Doppler shift up. But that shift depends on how fast you're going relative to the source. And if you have cruise control set at 30 miles an hour, you're going to have the same shift all the time. It's going to sound louder and louder, but it's not going to sound higher and higher. It will sound higher than the whistle normally sounds, but it won't get higher and higher as you get closer and closer. Now here's an old exam question. You have a child on a tire swing. We're just going to look at the motion as the child goes from A to E. We won't look about coming back. And there's a whistle creating a constant frequency. Now the child hears different frequencies at different locations. At what location would the child hear the highest frequency? Would it be at B, moving towards C, or at C moving towards D, or at D moving towards E, or at E? So with your clicker, okay, last call. Oh, we're all okay. Now, this shift above the rest frequency depends on how fast the child is moving towards the source. The shift will be greatest when the child is moving fastest. Now you remember the child speeds up as she comes down because of gravity, and she slows down as she goes up. So she's going the very fastest right here at C. So the correct answer to this would be at C, moving towards D. Okay, if you did something different, slap yourself right now. Okay? At that point, she's about to start slowing down. Think of speeding up all the way before noon, going faster and faster and faster, and right at noon, you're taking your foot off and hitting the brake, and you're slowing down all afternoon. When are you going the very fastest? High noon. Right when you're making that transition. Okay? Now, here's the key idea. Louder is different than higher. Okay? If we had a piano on wheels, and we were pounding the middle C key, and that piano was rolled towards you very quickly, what you would hear is something higher than middle C, like D. But as it got closer and closer and closer, you'd keep hearing the same note, D, 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 D. It'd just get louder and louder, okay? Which is different than higher and higher.